Howdy, welcome back. This is a new lesson today. Today's lesson is about naming compounds and writing formulas. Again, I'm Mr. Dang. I am in 503. If you guys need any help anytime from Ms. Carrasco's class, please stop by and ask questions, get your work done, review, tutorials, any of that. You can also see any chemistry teacher with the schedules posted on in front of my door on 503. Okay, and so before we start, let's review the periodic table real quick. You have the periodic table is divided into different sections. Okay, your first of all, you need to know where your metals are. Okay, and you have to know the metalloid. This is the metalloid staircase here. Everything to the right over here are non-metals, right? Metals are on the left side. Okay. Except for hydrogen. Hydrogen is a non-metal, which is up here in the top corner. Goes with the non-metals over here on the right side. Okay, metals on the left, and non-metals on the right, toward the right side. Right. Another thing we need to review is the number of valence electrons. Okay, so group 1 has 1 valence electron. Group 2 have 2 valence electrons. We skip the transition metals because their valence electrons are weird. Okay, then group 3 is 3 valence electrons, 4, 5, 6, 7, and everything here is 8 going downward, except for helium. Helium's only got 2 valence electrons. Because remember, the first energy level, for helium and hydrogen, they only need 2 to have a full outer shell. Okay, everybody else want 8 to have a full valence shell. And so that's very, very important to determine the what we call an oxidation number. Oxidation number. And you have to know this for this bonding unit. Okay, the oxidation number is the charge of the element of the ion once it gains or loses an electron. Okay, so if this column, the first column, for example, it only has 1 valence electron, it's going to tend to lose it because it can either gain 7 to make 8, or lose 1. So it's likely going to lose 1. So if it loses 1, it's going to be positive 1. So this whole first column is positive 1. Okay. Hydrogen is likely to lose or gain 1, or lose 1 to make 2, but we'll talk about hydrogen later. And then column 2, it's got 2. It can either gain 6 to make 8, or lose those 2 to have a full shell underneath. Okay, to lose that whole shell, so there's a full shell underneath. And so this is plus 2. Column 2 is plus 2. We skip over the transition metals. Then we go to group 13 here. Group 13, we have 3 valence electrons. We can either gain 5 or lose 3. What's more likely? We're going to lose 3, so it's going to be plus 3. Okay. And then group 14, it has 4. It can gain 4 or lose 4. So ideally, it can be positive or negative 4. Okay, gain 4 or lose 4, equally likely. And we'll talk about that later. What's more likely going to happen? We'll talk about it later. Group 15 here, 5 already. It's closer to 8 now. So then it's going to add 3 electrons, so it's going to be negative 3. Okay, negative 3. And then oxygen group here, it's got 6 already, so it's going to gain 2 more, so it's going to be negative 2, because it's gaining electrons. And the next group, you probably have already guessed it, is negative 1, because it's already got 7. It's going to try to gain 1 more electron to make a full shell. And then group 18 over here, of course, they're full. They're not likely going to gain. So then no, oxidation number is 0. They will not gain or lose any electrons. So you need to know that in order for you to do this next part. Okay. So quick review. Mark up your periodic table. Group 1 will be, we'll have 1 valence electron, so it's plus 1. Group 2 is plus 2. All of them in that group. Okay. Group 13 plus 3. Group 15 minus 3 minus 2 minus 1 for 17 there. You can skip over group 14 and now because more likely the silicon and carbon will not form ionic bonds, so we will not need to worry about the oxidation numbers anyways. And then we have lead, which is a little special down here. It could be lead, I think it could be lead 2 or lead 4, so that's special as well. So okay, and so knowing that, it'll help us get this first part done correctly. Okay, bonding basic. You should have this packet of 9 pages, 10 pages in front of you. It's a lot of it's a lot of pages. You're supposed to glue all this in and have all this done fairly soon. Okay, so atomic symbol. I'm going to walk you through a couple of these, and you are expected to do all these on your own and then check with your teacher for the answers. Okay, chlorine, atomic symbol Cl. That's just the symbol. Total number of electrons, which is what? Which is the atomic number. Which is here, chlorine, right there. Atomic number 17, so it's got 17 electrons. Number of valence electrons. How many electrons on the outer shell? 7 valence electrons. Okay. I have a habit of putting that E minus, just kind of like in my unit. Okay. And number needed to gain, so it needs to gain 1. So if it gains 1, it's going to be -1. Okay. That corresponds with our -1 on the periodic table. Okay. So we're just going through practicing this to know whether or not it's going to gain or lose electrons and get the oxidation numbers. Go down to potassium. Fine. Potassium, number 2. Second one. Potassium is right there. Symbol's K. Total number of electrons is 19. The number of valence electron, it's in group 1. So then it's 1 valence electron. So it's easier to lose that 1 than to gain 7 more. Okay? Atoms are pretty lazy. They don't want to do more work than necessary. So losing 1 is more likely than gaining 7. So lose 1. If it loses 1, it's going to be +1. Alright. So let's go down to carbon. Carbon's letter C. Okay. Carbon's atomic number is 6. Right there, right after boron, and then carbon, and then nitrogen, right between nitrogen and boron. Atomic number 6. It's in group 14, so it's got 4 valence electrons. Okay. So it's likely to gain or lose, so it could be plus or minus 4. It can gain 4 or lose 4. Same, equally likely. Alright. So complete this table. And then we'll continue moving on to pause this video, complete this table first, answer these couple questions down here, and then we'll move on. An atom that gains 1 or more electrons will have a negative charge. An atom that loses an electron will have a positive charge. An atom that gains or loses an electron is called an ion. A positive ion is called a cation, and a negative ion is called an anion. Okay, very important concepts down here, very simple. Read over a couple times after you write it. Review it over a couple times over the course of the next couple class periods. Okay, and when you're done with that, let's talk about this first bond, which is called ionic bond. I am going to zoom this in. Okay, zoom this in. There you go. Very blurry. Very blurry, perfect. Requires your concentration. So, an ionic bond, atoms will transfer 1 or more electrons to one another to form a bond. Each atom is left with a full outer shell. An ionic bond forms between a metal ion and a non-metal ion with a negative charge. So you will see, ladies and gentlemen, it's always the key to ionic bond is metal plus non-metal. Okay? If you know that, then you can recognize an ionic bond right away. Why is it a metal, non-metal? Because earlier we mentioned the periodic table. Metals are on one side of the periodic table, non-metals are on the other side. Okay? Metals are on the left side, non-metals are on the right side. Okay? Metals will always have a positive oxidation number. Metals will always have a positive charge because it's going to give up electrons. Non-metals, on the other hand, they're greedy. They already have 5 or more electrons on the valence shell, so they want to gain electrons. So that's why it's more electronegative over here. Remember the word electronegativity? Electronegative. More electronegative because they want those electrons more because it's easier for them to fill their outer shell. Okay? So, back to this paper here. Sodium is in group 1. In order to do this, you also need to know how to draw your Lewis dot. Okay? So sodium is in group 1. So sodium, it's got 1 dot. You draw it like that. Chlorine's on group 17. It's got how many dots? It's got 7 valence electrons. So you draw 7 dots around there. Okay? So what's likely? Who's going to lose? Who's going to gain? Sodium will lose this electron to chlorine to fill this empty spot that it's got right there. It's got an empty spot to make 8. So sodium will lose that. Sodium will become positive. So you write like this: sodium positive 1, and you write as a positive sign, plus. And then chlorine, it gained an electron, so you write as Cl minus. Okay, positive Na, Cl minus, because Cl gains an electron, and this is your table salt. Okay. What happens in the future? We talk about if we throw this in the water, they split apart into Cl minus and Na plus, and we will talk about that later. Magnesium iodide. Magnesium, Mg. It's in group 2, so it's got 2 dots. Iodine, group 17, so it's got 1, 2, 3, 4, 5, 6, 7. Okay. So magnesium must lose those 2. It has to lose those 2, and iodine needs 1 more. Needs 1 more to fill its outer shell. So what's going to happen here is magnesium's going to give iodine this electron so that it can fill that last spot. Okay, so then we have that iodine, but magnesium needs to lose 1 more down here. So we have to bring in another iodine. So we have to give away completely, and this iodine will have 7 as well, with 1 missing there to fill its outer shell to be 8. So this magnesium will give that last 1 to there. So magnesium, in turn now, it loses how many electrons total? It loses 2, so it's going to be positive 2. Magnesium is positive 2. And iodine, each of them will gain only 1, so it's minus 1. Sometimes we only write the negative sign to represent minus 1. But there's 2 of them. Okay? We brought in 2, so the equation for this, Mgi2, that is the equation. 1 Mg will give 2 electrons, 1 each to each iodine. Yes. Good. So try B3, B4, B5, B6. Pause this video. Try B3, B4, B5, B6, and once you play again, the answer will be shown to you. Okay. So once you hit play, the answer will show to you. So pause it, try it. Don't just let it play to copy it. So Okay, there you have it. Hope you guys have tried that on your own. Ladies and gentlemen, it serves you no purpose to just copy it. So make sure you know how to do those. Okay, we will go back to the covalent afterwards, but right now we will just go on to the next page so I can teach you how to write formulas here. Alright, so today this is the last thing we'll do as far as in this video. Oxidation numbers are the numbers to indicate how much electrons have been gained or lost. So there's a little table up on top for reference. You can always reference back to your own periodic table. So group 1 is 1 up here. So group 1 is 1. Group 2 is 2. 3 is 3. And then 13 is 3. And then 15 is -3. -2, -1. Okay, so refer to that. So this is how it works. Sodium is -1. Sodium is +1. Chlorine is -1. So you write the charges on there. And so you follow the example up here. You cross those numbers over if they are not 1. Okay. So if they're 1, you don't cross them over. So the formula is Na and Cl. They cancel each other out. +1 and -1. So the name, it says, how do you write the name? Name the first element, which is the metal ion, which is sodium. Change the ending of the second element to IDE, chloride. Chlorine becomes chloride. Okay. And so this only works for binary ionic compounds. Binary means 2 elements. Ionic means metal plus non-metal. Okay, 2 elements, metal plus non-metal. And it has to be one of these elements in group 1, 2, 3 through 13 to 18. You cannot not transition metals. There's something special about transition metals right here, which we'll talk about in a little bit. Okay, and then Ba, it's in group 2. Ba is in group 2 here, so it's +2. F is -1. So the question is, how many fluorine do you need to balance out that Ba? Okay, and by crossing it like this, it'll bring the 2 down, so it becomes BaF2. That'll give me 2 fluorines to balance out 1 barium. All right. And then you have the transition metal here. All of a sudden, there's transition metal. Transition metals, they're different. The oxidation number changes. The charges changes for the element. Like iron here, you have iron +2 and iron +3. 2 different iron. Okay. So bromine is -1. Bromine is -1. So we cross that 2 down over here. Since it's a 1, we don't need to worry about crossing it, because a coefficient of 1, a subscript of 1, we don't need to put those. So it's FeBr2. Okay. Then you cross this 3 over, FeBr3. The difference between transition metals and non-transition metals are like this. So iron, it says if it has a transition metal, use the Roman numeral 1, 2, 3, 4, 5, if it applies, to indicate the oxidation number of the metal ion. So iron +2, so you write iron 2 in Roman numerals, and then bromine becomes bromide. Okay. If it is a transition metal, you indicate the charge with the Roman numeral. The next one would be iron 3 bromide. Alright, that's how you do that. So get the oxidation numbers, cross them so that it balances out. Okay, so for example here, nickel and oxygen. We're going to take a look at nickel and oxygen here. Nickel is +2, oxygen is -2. The oxidation numbers are the same. You can cancel them out and not cross them, so it's just NiO. Okay, but nickel is still +2, so you write nickel 2, oxygen becomes oxide. Okay, nickel 2 oxide. Then go down to CuCl2. Cu is copper. It's +1, Cl is -1. So the charges already balance each other out. You don't need to cross them anymore. Okay, they will bond with the same ratio. Copper and the charge is 1, and chlorine becomes chloride. Okay, the metal ion keeps its name. You only change the ending of the non-metal, the anion. All right, complete this page, and let's see what's next. Yeah, complete this page, and there will be a video on the next couple pages coming very soon.